Pterosaurs have always been seen as the biggest animals to ever fly on Earth, dominating the skies during the Mesozoic era. Although it was true, for some of them, other pterosaurs didn't fall into that pattern, being much smaller in the shadow of their huge relatives. However, even those small pterosaurs had some of the basic characteristics of the pterosaurs, such as a beak and a crest, even if tiny. But the family of small pterosaurs decided to throw that principle under the bus. They didn't have beaks and were really strange for pterosaurs, as we are going to see. That family was the Anurognathidae. This family is known from the Upper Jurassic to the early Cretaceous of China, mostly China, as well as Kazakhstan and Germany. As it happens, most of the fossils have been found in, you guessed it, China. And knowing how weird many Chinese dinosaurs were, it is not at all a surprise that their own pterosaurs were peculiar too. The Anurognathidae are known since the 60s, but most of these studies are from the 21st century. The climate indicated by the rocks where they were found is mostly the same, warm, humid, in an arboreal environment. It is quite normal to find pterosaurs living in forest environments, at least at the Jurassic era, where most of them are still tiny. They were, however, quite generalist, and not with huge adaptations. The Anurognathidae, however, developed quite the interesting features to live in forests, as we are going to see later. In general, the members of the family are quite tiny, having an average wingspan of around 40 cm, like a blackbird or a small corvid. As said before, they are characterized by their absence of a beak, which isn't something only found, or maybe not found, in them. Several lineages of small pterosaurs did have a beak, albeit tiny, like the well-known Dimorphodon or a Dimorphodon. Yeah, paleontologists didn't go very far to find its names. What characterized them the most is the form of their head, semicircular to even elliptical in some genera. They kind of looked like bats or carlins. Maybe the title of this video should have been the carlins of the Mesozoic, which would have worked well too. Finally, they had large orbits, perhaps suited for nocturnal lifestyle like most current bats. In terms of classification, Pterosauria, and not just pterosaurs, is usually separated into two groups. The small, ancient Reptiles, yeah, I know the name, and the more recent and bigger Pterodactyloidea. The Anurognathidae, as you have probably guessed, are members of the first group and one of the last families to go extinct. In terms of phylogenetic positions, they are actually one of the most derived groups of Rhynchoranchoidea, being very close to the first Pterodactyloidea. And as that superfamily is paraphyletic, which means a group of organisms that includes a common ancestor and some, but not all, of its descendants. The Anurognathids are actually more closely related to the Pterodactyloidea than with other families of ancient pterosaurs. Thus, Anurognathids share traits that are normally only found in the Pterodactyloidea, such as the fusion of the first and second cervical vertebrae, or the presence of a naso-antorbital fenestra, which gives its name to the group containing Anurognathids and Pterodactylidea, the monofenestra. And yes, those tiny flying carlins mimicking bats are in fact the ancestors of the giant pterosaurs from the Cretaceous, then the other groups of small pterosaurs from the Triassic and Jurassic. Anurognathidae are themselves split into two subfamilies, the Batrachognatinae, named after Batrachognathus, whose name literally means frog mouth, due to the specific form of its jaws, and the Anurognatinae. Several anatomical differences distinguish them. The Batrachognatinae had elliptical jaws and a reduced humeral dectopectoral crest, which is an extension of the humerus, where muscles are attached. The Anurognatinae hadn't this reduction, plus the jaws were different, more semicircular than elliptical. Those two subfamilies hold different genera, from the small Dundrocoides to the giant, according to Anurognathidae standards, Geolopterus with a wingspan of over 90 cm, which is the same than big European pigeons. Or carling or bat-like pterosaurs with a wingspan of a pigeon. Who knew we could put so many animals into one? That made the mixed creatures from Avatar so simple. But what they lacked in size was made up by distinctive features, such as their teeth. Like most Rhynchoranchoidea, Anurognathidae had teeth. They vary in terms of forms and size. The dentition of Anerugnathus is homodont and was referred to as puppeiform, giving their resemblance to dipteran pupae. The teeth of Vesperipterus were relatively stouter. The pigeon bat calling what you want. Jolopterus had longer and more recurved teeth like Batrachognathus. Finally, the teeth of Lupterus were quite unique. That genera had heterodont teeth, which means different types of teeth inside the mouth, like the incisives, canines, premolars, and molars seen in most mammals. In Lupterus, the front teeth were slender and sharp, whereas the back teeth were shorter and more robust. Anerognathidae also had differences into their tails, long in Batrachognathus and Dendrochroides, reduced in Anerognathus, even absent in Geolopterus. Those differences can be probably explicated by their lifestyle. The tail served as a balance pole during flight. A reduced tail indicates perhaps less flying. Knowing the environment where they lived, which was arboreal, at least Anerognathus moved less by flying and more by climbing. In a larger sense, most of the Jurassic genera still had long tails, whereas their Cretaceous counterparts had reduced ones. Perhaps it shows that the Anerognathidae transitioned from an aerial and arboreal lifestyle to a more based arboreal one, maybe due to competition with other flying reptiles, and perhaps also birds. Yet, that assimilation isn't probably a good reason, as the big Cretaceous Pterosaurs also didn't have tails or were very reduced. It also should be considered that Geolopterus, who lacks a tail, is also the largest member of the family. Perhaps the true reason, or at least a more reasonable one, is the size factor. Big pterosaurs don't need a tail to serve as balance, as their being wings powered by huge muscles sees that function to the tail, making it useless. However, it wouldn't come as a surprise that after mimicking carlins, bats and frogs, a genera decided to expand the number of animal mixed by having primate characteristic. Yeah, you heard it right, the little guy is named Vesperipterus and like most primates had a reversed first toe. That quite interesting feature would have made him a champion at gripping. Along with its reduced tail, it was likely arboreal, climbing or clinging to tree branches with curved, sharp claws and used less often its flying abilities. That led to mind-blowing representation. So you guessed it by me repeating that information so many times, but they were arboreal, yes, and also nocturnal. You probably forgot about that as I didn't repeat it 1,000 times. As for the different teeth, it probably indicates a different diet. Geolopterus and Batrachognathus have been hypothesized to have been pecivorous, using their long, sharp teeth to dart into the water and grab fish swimming near the surface. As for the others, they were probably insectivorous. With their very large eye sockets and rodent head, they would have had a great eyesight. They could then quickly spot insects and be able to follow their motion while following behind them. Due to their small expanded body, as well as their very flexible joints, Anerognathids would have had a great movability to catch the small insects and prey they were chasing. Certain species, more tree drilling than flying, would have used their claws or reversed first toe to match closely to tree bark or dark night colors to blend in and ambush insects for nocturnal hunting, just like what is seen with modern-day nightjars or bats. The heterodont teeth of Lupterus indicate another degree of specialization into eating insects. While the slender long teeth catch the prey and kill it, the shorter and more robust back teeth grind its shell, making the digestion far easier. Why only that genera possessed those types of teeth and not the other is still a mystery today. Akin to bats, Anerognathids are widely believed to have been nocturnal or crepuscular. But if they looked light and had a similar lifestyle as seen in bats, one question remains. Did, like bats, they have echolocation? Even though it would have been incredible to discover pterosaurs and in a larger sense reptiles capable of echolocation, the anatomies of their cranium clearly show that it wasn't possible. Bats able to echolocate have really distinctive heads, with their auditive components very sophisticated and easily recognizable. Even if they didn't have echolocation, Anerognathidae have nothing to envy from bats, as they possessed their own way of sensing their environments, in a manner not seen before in the fossil record. To begin with, Anurognathidae, like all of the pterosaurs, had a strange equivalent to hair called pycnofibers. They covered the head and the back of their bodies. Pycnofibers are typically of one form, straight and robust. But the discovery of two well-preserved fossils of the genera Cascopoda in 2018 shows a clear difference in the pattern of the pycnofibers, as 4 types as found in just those 2 specimens. More incredible, but some of those types look like prototype feathers, so maybe feathers and pycnofibers come from the same initial structure. Moreover, one of the type of pycnofibers, the type 3, kind of look like a very primitive feather. This type is also found in the first dinosaurs to possess true feathers. The researchers from the studies presenting the different type of pycnofibers also gifted us that incredible tree. It not only shows a different group of feathered and pycnofibered animals, with birds at the near end, but also the different types of branching possessed. The famous type 3, found in Anurognathids, was also present in the first feathered dinosaurs. And as we get closer to the first birds, the type 3 gradually disappears from the fossil records, letting only the true feathers in birds. As for our Anurognathids, such diversification in pycnofibers, as well as the presence of feather-like structures, suggests that Anurognathids, and potentially other pterosaurs, possessed a dense filamentous covering that likely function in thermoregulation, tactile sensing, signaling, and aerodynamics. No need for echolocation if your body can directly help you navigate far more efficiently than other animals. To conclude, Anurognathids represent probably the cutest pterosaurs to ever lived. I mean, look at them, aren't they cute? It would be so nice to not only have them represented in drawings but also games. Couldn't be that nice? One question left to ask: how did they went to cute living beings to cute extinct beings? Like always, it is not one major cause, but rather an accumulation of several reasons. Anurognathids vanished from the fossil records at the beginning of the Cretaceous, which coincided with the appearance of the first feathered dinosaurs like Microraptor or Sinornithosaurus. Anurognathids would have either been in competition due to the same sources of food or being hunted by the largest of them. The entrance of the first true birds in China, Confuciusornis for example, also insectivorous, would have caused another pressures at our small and already burdened Anurognathids. The advantages of birds in the sky would have caused quite a lot of damages in the Anurognathids population. Finally, those little flying curlings were extremely specialized, having a ton of incredible features that made them unique. However, ultra-specialized animals are usually the first to being impacted by a change in their environment. Therefore, Anurognathids were so vulnerable to any changes that the arrival of new habitats in their forest, and perhaps climate change, impacted them the most comparing to other animals at that time. What caused their success will have ultimately caused their downfall. I wanted my first video on YouTube to serve as a tribute to those tiny cuties. While quite cute and amazing, just look at the final numbers of animals who can mix in them. The data extracted from their fossil remains gave us huge information regarding the evolution of feathers and the complex ecosystem during the Mesozoic era. They also help us broaden our visions about the pterosaurs, and while they are mostly known as those big animals able to fight a T-Rex, according to some movies, some families didn't fall in that scheme but are equally interesting. Thank you for watching, I hope you learned something interesting. If you enjoyed this video, feel free to like, subscribe and comment. Sharing this video will also help me a lot. Finally, follow me on Instagram and Twitter to get more in touch with my content. See you soon!